So 7.1 and 7.2, graphing exponential growth and decay functions.
Do we need graph paper for this?
No. So basically, things that you're going to need to be able to do with this is you're going to need to be able to determine, is this a growth or decay function? If you don't recognize it just by looking at it, you can always plot points and you'll be able to figure it out. And then domain and range of them, which is super easy because, well, you'll see why in a second. So the parent function for exponential growth, so we have the function f of x equals b to the x, where b is greater than 1, that's the key part there, is the parent function for the family of exponential growth functions with base b. And so a rough sketch of what this looks like. Let me turn this off. Okay. So we have our little graph set up here. So basically, our growth function is going to look something like this.
Whoa.
Okay, now the base function has a point here at 0, 1. And then it would also have a point at 1 and b. So whatever, like basically, obviously x is 1, then it's just b to the 1, which is b. Would be on there as well, and then obviously we could keep plotting points in the negative and positive direction, and it's going to keep basically in the negative direction. It's going to get closer and closer and closer and closer to 0, but it's never actually going to touch it. What does that mean exists right here?
Infinite solutions.
A bunch of points.
What does this dotted line mean, or what is that?
It does not include it.
What's the fancy name for it?
Any.
Oh, they were talking about
Starts with an A.
when I got my haircut.
Less than
Really?
absolute value.
Remember the picture, Zach?
There are vertical and horizontal ones. This one happens to be
Asymptote.
horizontal. Yep.
Oh, I don't know what that word means.
I was trying to say asymptomatic. I was like, I don't know.
Yes, it's an asymptote, means it can never cross it. So, I mean,
Kind of.
She wrote in
I-
notes.
we've talked about asymptotes before, so you should already know it, but
We did not.
Are you talking about?
No, I said we did not know it. I would never talk
so the domain of a exponential growth function, and also it's going to be for a decay function. Domain is going to be all real numbers. Remember the fancy R is all real numbers. Or you can write it as negative infinity to positive infinity.
Ew. I like the fancy.
Typically, we just write fancy R. Now, the range would be anything y greater than 0. It can't be equal to 0, so it's going to be a parenthesis. So 0 to infinity, because it goes up to infinity, but it never touches 0.
None of us had written down what the fancy R meant like last time, so we were all really confused and like trying to figure out what the R meant. And none of us had written it down. We just all had written down the fancy R, but none of us remembered what it was.
Me too.
Yes,
I knew
all
what
real
it was.
numbers.
Yeah, he knew. He just wasn't. Huh?
Oh.
Yes, I was. I was here every day.
Why did you say what it was?
I was afraid of arguing over it. I started doing a lot because I had to cram for it.
All right, then we've got the parent function for exponential decay. So obviously going to look similar, but it's decay function. So the function f of x equals b to the x, where 0 is less than b is less than 1, is the parent function for the family of exponential decay functions with base b. Now, notice, b is between 0 and 1. It is not negative. What would a negative imply?
Be on the bottom.
Yeah, it would be reflected, so it would be flipping it over. And so basically, just note that it's essentially, if it is a fraction that's less than 1, then it's a decay function. The other thing you have to be, well, never mind. We'll get to that later. So then a picture of this one, like with the other one. Line is not straight. And so typically, unless it's negative, you really only need the top of the graph. So I usually make the top kind of like dramatically larger than the bottom. But it's up to you. So a decay function is going to be something like this. So it's basically just flipped of the other one. We still have an asymptote here that can't be crossed. We have the point 0, 1 and 1b. And again, this is the function f of x equals b to the x for 0 less than b less than 1. Why are my less than so you can like see? So the domain of this is still all real numbers, and the range is still 0 to infinity. Now, that's obviously for the parent function. When we are graphing them, if there is a plus or a minus, these graphs may have been shifted like up or down, and so that's going to affect the range. The domain will 99.9% of the time be all real numbers. I'm saying that because I can't think of a situation right now where it's not, but in case there is, I'm leaving that 0.1 just in case. But basically the domain has to be all real numbers for an exponential function. But the range will shift if the graph has been shifted. So just note that. All right, so I'm going to start out in some 7.1 problems, which means that we'll be dealing with growth first, and then we'll go to a couple decay problems for 7.2. I may go back and do some interest problems after. We'll see. I don't know. All right, so basically all we're doing is we're doing the graph the function, and then we're going to state the domain and range for these problems. So these ones are from 7.1, which is page 482. Just noting that since we'll be in two different sections. All right, so starting off with relatively easy one, number 8. F of x equals 5 times 2 to the x. So I like to do this with a table method, and honestly, I usually just use -1, 0, and 1. They're the easiest. Now, if I know a graph is getting shifted or I have some pretty dramatic numbers that things are being multiplied or divided by, I may adjust a little bit, but that kind of just comes with time as far as like what that looks like. So I'm going to start out by doing a table with just -1, 0, and 1. So I always do a little XY table here. So -1, 0, and 1. And I usually just kind of do the math below it if I can't just do it in my head, but a lot of times I can just do them in my head. Algebra 1, I had to like put a whole like middle section of the table so that they would actually do the math and not just attempt to do it in their head. Anyways, so if I plug in -1 for x, what happens to this? Like, huh?
Put
Yep.
it where it is.
1/2. Well, yes. Put it where it ain't, make positive. Okay. So that causes it to be 1/2. So I have 5 times 1/2, which is just 5/2. If you prefer, because we're graphing, to write it as 2.5, that's fine. What would happen if I plug in 0 for x?
5,
Can be 1.
0, 1.
Well, yes. 2
1
to
times
the 0 is 1 times 5 is 5, so I'm just writing it that way. And then if I plug in 1, what do I get? 10. So, to graph this, like I said, I usually just only do the top. If you're counting by something other than ones on the y-axis, you need to label that. If it's like up to 10, I usually just count by ones, but beyond that, a lot of times I'll start counting by like 2s or something. So, I'm just going to note that that's 10 so I don't have to recount when I do this. So at -1, I'm at 2.5. So that's up here. At 0, I'm up at 5. At 1, I'm all the way up at 10. And so my graph is going up like that. Clearly, that's a growth function.
It's because it's going up.
Domain is all real numbers. And the range on this one is still going to be 0 to infinity, because this one, while the numbers are higher up, it would still just never cross here. It's only going to be, the range is only going to change if out here this is plus or minus some number, basically. Let's see, 12. Y equals 3 times 4/3 raised to the x. So just looking at this, even though this is a fraction, it's bigger than 1, so this has to be a growth function. So again, I just like to use my -1, 0, and 1 when possible. And I trust that you could plug in any number if it was given to you. Like you were forced to do something else. But I like to use the basics. So if I plug in -1, what do I end up with here? 3/4 times 3, which is 9/4.
Huh? Oh.
What about when I plug in 0? 3. 4/3 raised to 0 is 1 times 3 is 3. And then if I plug in 1,
12/4.
4.
Oh.
So, set it up again. So I just need to go up to 4 this time, so. So at -1, I'm at 9/4, so that's like, what, 1 3/4 or something like that, so. In there. At 0, I'm at 3. At 1, I'm at 4. And so notice, because of how tight these numbers are together, it's not going to look super rounded, but I still want to try to make it look as rounded as possible. So it's just not happening. I caught it. It's not happening as dramatically as some of them. Some of them it increases like very, very quickly up. And some of them it like happens more slowly. This one's happening more slowly. Let's see. 18. Whoa. Y equals 3 to the x minus 2 minus 1. So notice this one has stuff like it's not just 3 to the x, it's 3 to the x minus 2. And then ultimately it's also minus 1, so that's going to basically be causing our graph to shift downward. So I may not want to use -1, 0, and 1 in here. Now, it's not going to be like that big of a deal with this particular problem, but there are times that you may want to choose different numbers. Yeah, like 2 might be good. So maybe instead of doing -1, 0, and 1, maybe this time I'll do 0, 1, and 2. Because I like to try to get it to where I will have something raised to the 0, because obviously that makes my life easy. So let's do that this time. Instead of doing -1, 0, and 1, let's do 0, 1, and 2. So when I plug in 0, I end up with 3 to the -2 and then minus 1. And so 3 to the -2 would be what?
1/9.
Yep, 1/9 minus 1. So this might be where you want to actually do something like this. So this would be what? -8/9. So I'll know that that's relatively close to 1, but not quite there. Interesting.
It's gonna be -2/3.
Yeah. So then this would be 1/3 minus 1.
So should we, well, not should we, could we have used 2, 3, and 4, and would it have been less fractiony?
That's what I was thinking.
Yeah. I may extend and keep going, and then we'll just choose which points we want to use just so that we can see it. But yes, I was not yeah.
So why is that weird? Like, why does that happen?
Because it's negative.
Like, what's wrong with or is there anything wrong with it, or is it just like whack?
No, it's just weird. I'll explain why it looks weird to me in just a second. But I want to finish the problem and then I'll explain it, because if not, you're just going to be confused. Because I see something that y'all probably don't see yet. That's why.
I see it.
Oh.
Okay, so what happens when I plug in 2?
To
-1.
-1. And then if I keep going, 3 and 4, let's do that just to see. So at 3, what do I get?
2.
And at 4?
8.
8. So yes, it might be easier to do this. I'll actually plot all 5 on this one just so we can actually see what's happening.
Shouldn't it be 0 for the 2? Because it's 1 minus 1. Yeah.
Yeah, who said it was -1?
Ryan.
Sorry.
Dummy.
Where's my bonus when you say that?
You only said it one time.
I like those numbers better.
They make me feel better.
0 to
It's not about you.
It's not about you either, so I don't care what you're talking
I don't care about your face.
about, bro.
Yeah.
All right, so I'm going to plot all 5 of these points just so that we can see this,
How do we have to cross?
but it's been shifted.
Okay.
That's why.
What?
All right, so at 0, it's -8/9, so it's almost down to -1. So in here, at 1, it's -2/3. At hello?
Hey, can you pick up?
Yes.
I was simply one girlfriend's
Really?
my sister.
Okay, so they need to be there at 10.
We beat the vector tracking for the
Okay, perfect. Thank you.
Can I leave?
No, you're not going.
Daniel.
Are they coming?
Y'all can go in 5 minutes.
Who's y'all? Me?
Just Daniel.
No, Daniel and Charlotte.
Oh.
At 2, it is 0. At 3, it is 2. And at 4, I don't know why I went out to 5. 4, it is 8, which is all the way up here. So the place that it can't cross is -1, because normally it's 0, but it's been shifted down 1. That's what that -1 is telling me. And so I was looking at the negative numbers thinking they looked funny, but then that's why I was looking at it and I was like, what is going on? But then I realized because it's -1, the asymptote has been shifted down to -1.
So the constant is always like what it shifted, what in the function, because the constant is -1 in that function.
Yes.
Okay.
The minus or plus whatever will end up telling you where your asymptote's moving to.
Okay.
All right, I'm going to jump to 7.2 super fast to try to do one before they go. It's basically the exact same thing. It's just going to be fractions, more or less.
Yeah.
Let's see, number...
I hate fractions.
Okay. Number 8. Y equals 1/3
Man, take your
raised to the x. So I'm going to go back to just -1, 0, and 1 here for these ones.
Yay. I like it being simple.
So 1/3 to the -1 is
3.
3.
1/3 to the 0 is
1/3.
no,
One.
1.
1.
1/3 to the 1 is 1/3. Yep, so this is a decay one. I didn't note this, but this is 7.2, page 489. So -1 to 1, and we go up to 3. So notice at -1, it's up at 3. At 0, it's at 1. At 1, it's at 1/3. And so this one is basically just flipped.
So there's a. Oh.
You good?
No.
You know why?
Because LeBron.
All right.
Old.
One more, and then that's it. 14. H of x equals -3 times 3/8 raised to the x. So this one's probably going to end up being kind of weird because there's a negative being multiplied in front here. What does a negative usually do?
Flip it. I mean, down it.
Yep, reflect it. So -1, 0, and 1. So if I plug in -1 for x, what happens?
It's just -8.
Yep, so this will end up being -3 times 8/3, which just is -8. If I plug in 0, what do I get? -3. If I plug in 1, what do I get? -9/8. So then this graph here, notice this one's a negative number, so I actually need to go down on the bottom this time. So at -1, it's -8. At 0, it's -3. At 1, it's -9/8, so just a little bit bigger than 1. And again, this one would keep going. The asymptote would still be at 0.
Does that mean it's a decay or
This is a decay because this is a fraction. It's just a reflected decay problem.
I was so confused because like I didn't see what you did, and I was like, it's humping like.
Yeah.
What?
It's moving to the other side. I was.
All right, 7.1. See, 7.2, just do 9 and 13. 7.1, go back. 7 and 13, and then one of them that's been shifted. Let's do 17. And I didn't really do a good job of writing this, but do the domain and range on the ones that you're doing the homework for. I don't know if it technically says it, but Daniel and Charlotte, you can roll. And you're going to the youth house, I assume you know